In this short video, I want to just explain Galileo's law of free fall. So the big idea is, where does this number g equals 9.8 come from? Why is the acceleration the same for all objects, no matter what the mass is? So that's really kind of the one thing I just want to talk about. And part of it comes from Newton's second law. Now, one way we often see Newton's second law is that F equals ma, where the force, or the net force, is equal to the mass, or the inertia, times the acceleration. But a better way to think about this would be to say that, hey, the acceleration is equal to the force divided by the inertia. And if I were to write those words out, I might say, hey, the force divided by the inertia. Now, in this case, what force are we talking about? We're talking about gravity. If we're talking about this on Earth, we're talking about weight. So really, the acceleration that we're talking about, where does this g come from? We're talking about weight divided by the inertia. And we could get into a rigorous mathematical proof in another quick little video. But the basic idea is this. If I have a really small object, then the weight is really small and the inertia is really small. Whereas if I have a very large object, the weight is very big and the inertia is really big. And it just so happens that this proportion, on Earth, we call it g, and it happens to be 9.8 meters per second squared. And that's the big idea of Galileo's law of free fall, is that as the weight increases, so does the inertia.